We have to be very careful when calculating areas under curves when some of the curve is below the x-axis. So what we're saying is that we might have a situation like this, and we'd like to find this area. Now, in all three parts of this example, I'm using x cubed. You know the indefinite integral of that is x to the 4 over 4. So for this first one, we have x to the 4 over 4, evaluated from -2 to 2. Using the top limit, that's going to be 2 to the 4, which is 16 divided by 4. Take away, -2 to the 4 is also 16. So this is actually 4 take away 4, which is 0. If we just do the integral from -2 to 0, then that's going to be x to the 4 over 4, -2 to 0, which is 0 if we put in the top limit, take away 16 over 4, which we established over here, giving us -4. Okay, let's just bear that in mind, that the answer came out as negative. If we do this one, again it's x to the 4 over 4, but we evaluated from 0 to 2. That's going to give me 16 over 4 take away 0, which is +4. Now, let's look at the area between y equals x cubed and the x-axis from -2 to 2. The integral from -2 to 0 gives a negative result as the area is below the x-axis. That's this area just here. The integral from 0 to 2 gives a positive result as the area is above the x-axis. Because of symmetry, the absolute value of the two integrals is equal. So we were talking about this area then. The integral from -2 to 2 is 0 as the area below and the area above cancel. Now, why was it that this result turned out to be negative? Think back to when we were doing the rectangles. We know that the height is y, but we're below the x-axis here, so y is negative. So if we think of the area as being y dx, where y is the height and dx is the width, then when y is negative, this is going to come out to be negative. But of course, an actual area cannot be negative. So the point is here that doing the integral from -2 to 2 of x cubed dx doesn't really give us the area. The actual area here would be, this would be 4. The negative just indicates it's below the axis. This is also 4, as we saw. And so the actual area is 8. You just have to be careful that areas below are going to give you negatives. Now, in the case here, we can see visibly that we have area. We know that that's not 0. But where you really have to be careful is if you had a situation like this, and you were working out the area from, say, A to B, this tiny bit of area below would cancel out. So what you really need to do there is treat the integral from c to d separately, and then take the absolute value of it and add it on to the area there and there.